All right. So we are looking at an intro into angles today. Okay, angles. So we got some definition stuff. We've got some classifying. Okay, and then at the end of the lesson, we will get into our first construction of the year, where we use the protractor, the compass. Okay, that'll be at the very end, so we don't need that stuff out right now. We don't need to be distracted by it. Okay, we'll get that at the end. For now, first thing is we need the mathematical definition of an angle. We all know what an angle is, right? We've seen angles, we've talked about angles, but the actual definition of an angle looks like this. It's a set of points consisting of two different rays that have the same endpoint. Okay, so again, you gotta be able to recognize that on the test as being an angle. A set of points, two rays that have the same endpoint. Okay, that is what an angle is. Now we know what an angle looks like. The vertex is where those two sides meet. The sides, of course, are just the rays, the sides of the angle. That's vertex. The important part here is how do we name it? Because one, we talk about naming point, line, plane, ray, all that stuff. Now we're talking about how do we name the angle. There are three ways to name an angle, and I'm going to write them in order of preference. Okay, some of them you can't do all the time. But if we can, if there's a number inside the angle, use that. Okay, so if there's a number inside the angle there, we would call this angle 1. Okay, this is angle 1. Just use that number, nice and easy. Angle 1. Angle symbol, right? Sort of like a less than symbol, but the bottom is flat. We got angle 1. Let's say that number isn't there. There isn't a number inside of the angle. Okay, well then we'll use the vertex. So then we would call this angle A. So that number's not there. Use the vertex, angle A. The problem with that though is what happens when I've got more than one angle at that vertex, right? We can't just name these angles angle A because we wouldn't know which angle we're talking about. How many angles are there here? Three. Remember, you can ignore, I can ignore that middle ray and have that big angle, right? So it's not just the smallest possible. We got to look at the bigger one. Okay? So there are three angles there that all have the same vertex. We can't name them all angle A. That's where the other points come in. So that's where we're going to name it using 3 points, one from each side with the vertex in the middle. So if we need to be more specific, if we have more than one angle at that vertex, we would call this either angle CAB or angle BAC, either way. Notice both of those have the vertex in the middle and then a point from either side on the outside. All right, so that's how we are going to name those angles, right? And we only need to use those three if there's more than one angle at first. Other vocab, interior versus exterior. We should know interior is inside, exterior is outside, right? The only thing to point out here is interior. You got to extend the sides of the angle. So like this point right here is still considered the interior. Because if we were to extend those sides, it's still on the inside of that angle. It's not just between the arrows, right? It's not just here, it's all the way extended. Okay, it's interior. All right, good deal. Questions so far? For the person next to you, I want you to name all the angles that are in this little picture. All right, name the angles.
Angle JML, JMK, KML, and JML, KML.
Or J, A, L. Mr. Radowski, if you're referring to like J or the angle JL, could you call it M?
No, like you're talking about the big one?
Yeah.
No, because if you just say M, we wouldn't know which one you're talking about. Yeah, unfortunately. All right, so raise your hand, give me one of the angles that's found. Jackson, what's one? JML. JML, that would be the big angle, right? JML is the big one. Lincoln, give me another one.
Or LMJ?
LMJ would be another way of naming that same one, right? LMJ would be another way. Give me a different angle here, Bree.
LMJ.
LMK, right there. Okay, clear?
JMK.
JMK. So we got 3 angles here. We got multiple ways of naming each one, but we do have 3 different angles here. Got to make sure we can identify all 3. Okay. All right. Good deal. Moving on. Our one postulate that we are going to talk about today, we'll talk about the other one that you have written down next week when we get into day 2. But the one that we're talking about today is the protractor postulate. The protractor postulate is another one of those common sense ones that we do without even knowing that this is a thing. Just like the ruler postulate was, we can measure a length of a segment. Protractor postulate says we can measure how many degrees are in an angle. Right? We know we can measure the number of degrees in an angle. The thing to point out here, the measure of an angle is just how many degrees it is, but we list it slightly differently. When you see an M in front of that angle sign, that stands for measure. So the measure of angle AOB would be equal to 140. So we wouldn't say angle AOB equals 140. We would say the measure of angle AOB equals 140. Anytime we're going to use an equal sign, we need to have the M there for measure. That's just one of those small detail things. I'm not overly concerned about it, but I will continue to point it out so hopefully you pick up on it. If we're going to say an equal sign, it's got to have that M. All right, so let's talk about how to use a protractor, because it's been a while for some of us. Okay, and you can just look at the one up here for right now. We have on a protractor, every single protractor is going to have some sort of crosshairs. Okay, a cross where 2 lines meet. That's where the vertex goes. A lot of them look like this. Sometimes it's just at the bottom of it, and there'll just be a little dash there, and that's where your vertex would go along the bottom of the protractor. So your vertex goes where those cross, and then one side of your angle needs to line up on that line. Okay, you got to line it up on that line. Okay, if I had an angle down here, that would line up on that line, and it would go up there. Okay, then we can take a look at where does that other ray cross, and we just need to know the difference between a 40 degree angle and a 140. Hopefully we know that, so we know this is 140. Just got it. The trickiest part, the only part that I see people mess up is lining it up correctly to start. Okay, make sure it's on that little crossover. Questions on reading a protractor? Yeah.
What if the line doesn't go like past it?
Then you're going to have to either extend the line, right? Or just visualize, put a piece of paper next to it along the line, something like that. So you can extend it. All right. Tell the person next to you the 4 different types of angles we're going to talk about. 4 different types of angles.
Acute, right, obtuse, straight.
And tell them what they mean. Tell them what they are.
Acute is less than 90, right is 90, obtuse is greater than 90, less than 180, straight is 180. That's not an angle.
Technically,
What you got?
All right, raise your hand. Give me one type of angle. And what is it? Right?
Acute is less than 90.
Okay, there's one. Free.
Right angle, which is exactly on.
There you go. Terrence.
Obtuse, which is more bigger than 90, but like less than 180.
There you go, between 90 and 180. And the last one here, Riley. There you go. So those are the 4 types of angles that we are going to talk about. You might have heard of a reflex angle. That's not one that we are going to deal with this year. A reflex angle is one that's bigger than 180. These are the ones that we need to worry about. So we got acute, right, obtuse, and straight. We got the definitions there. We know these. We've used these. The only one that we haven't used quite a bit is straight angle. And yes, that is just a line. But there are going to be times where we need to know, we need to be able to identify it as a straight angle so we can set it equal to 180 degrees. Okay, that's the only reason why we give it the name. Yeah.
When do we learn about angles that are greater than 180?
Probably algebra 2.
Okay, yes.
Yeah. If I remember correctly. Right. The only other thing to point out here, right angle, that little symbol, right, that box in the corner that represents that it is a right angle. It is 90 degrees. Technically, it's a perpendicular symbol, but we know that means it's a right angle. Okay. If we don't have that, and we don't know that it's a right angle, we cannot assume that it's a right angle. So if it's going to be a right angle in your drawing, you better put that little box. All right. So using all of that knowledge that we just talked about, here's a protractor. I got 3 angles listed. I want the number of degrees and what type of angle it is. See if we can get that done before lunch. Go ahead, talk some more.
GHK is 125. Right, 90. Right angle. L. K.
It's up to, or it's 2 and it's
35. Yeah. Finished. I was so still.
oh, yeah.
Oh.
Is that mine?
Yeah.
All right, here we go.
Okay.
GHK, how many degrees GHK? 125. What type of angle? Okay, JHL, how many degrees? 90. And what type of angle? Right angle. LHK, how many degrees?
35.
35. Remember, you don't have, just like a ruler, you don't have to start at 0. You can subtract the 125 from the 90 and get that to a 35-degree angle. And then what type of angle would that be?
Acute.
Acute. There you go. So when we get back from lunch, we will talk about congruent angles, and then we will be using our stuff for our construction. So now we have one more definition that we're talking about today, and then we'll get into our construction. Okay, we got congruent angles. We talked about congruent segments before. This congruent angles are very similar. Congruent angles are angles that have the same measure, the same number of degrees. Right? So congruent means equal. We already talked about how the M represents the measure of the angle, and that anytime we have an equal sign, we are using the M. So that's the difference between here and here. This represents the number value, the number of degrees for angle A and angle D are equal. The angles themselves are congruent. Right, that's what we say there. In terms of identifying congruent angles, from a picture standpoint, is we're looking for what are called arc marks. Okay, just like we had tick marks before, we have arc marks now. So our arc marks, they have to match up with the number of arcs. So like angle G and angle B match up because they have both have one arc. Okay, F has 2, D has 2, so those are congruent. We know for sure that those have the same number of degrees. Okay, that's all you are doing with congruent angles today, is identifying them in pictures. You have to be able to name them correctly as well. All right, any questions on congruent? Okay, we are going to do our construction now. So you need a protractor and a compass. You do not have your own, perfectly fine. I've got some over there. Okay, go ahead and grab one. Head back to your seats.
So we just need a.
Protractor and a compass.
Is this a compass?
Compass is a circle.
Got it. Why is it called a compass?
That's not gonna
That's so slick.
happen. Okay, hey, here we go. So put them down, okay? We're done playing with them. Give you the time. Give you the time.
I think
I
it's
did it.
Now, we are doing a construction. Let me preface this whole thing by saying these constructions are not meant to be the easiest, most efficient way of doing something. That's not what this is about, okay? Because I'm gonna walk you through a process here and you're gonna be like, oh, couldn't I have just done? Yes, there are other ways, faster ways of doing things. Not what this is about. What the standard is about, what we need to cover is being able to use these tools and use them in different ways than maybe you're used to. So we're not just drawing circles with that compass, okay? We're gonna use it as a measuring device and you'll see kind of what I mean as we go. So just, we're working on following directions. We're working on using these tools correctly and in different ways than we're used to. I'm not gonna ask you to do a construction on a quiz or a test, okay? You're probably not gonna have to do it on the homework since the homework's on computer, right? So this is just kind of a side note, an interesting thing, get us working with our hands and our tools to follow some steps, okay? So the first thing I want you to do with your protractor is I want you to create a 45-degree angle. Draw a 45-degree angle. Start with a ray, right? Start with a ray with an endpoint. Use your protractor, 45-degree angle. Get a different one.
Oh, it's like Kingman Flip. Broken.
Get a different one.
Only operator error.
You start with a ray, put your endpoint on there, line your endpoint up on your crosshair. Put a mark at 45, and then connect your dot.
Goodness.
Who was that?
So drawing.
Oh my goodness.
So you should have 45 degrees.
What if it's like 40?
You put a dot at 45 as connecting.
Yeah, it's about.
not bad.
Okay. Hey, call that angle B. Put a B for the vertex, please. B. B for the vertex. And what we're going to do here today with our first construction of the year is we are going to create a congruent angle to this. Okay, we're going to create a congruent angle, but we are not just going to use our protractor and measure it and draw. Okay, I told you there would be an easier way. We're not doing that easier way. We are going to use our compass and a straight edge. So that protractor we're just using as a straight edge. Okay. So what we need to do is we need to start that second angle. So I want you to just draw a ray. Okay, just draw a ray. And we're going to call the endpoint E. So it could be next to it, could be under it, could be on a different page. It does not matter.
Does it have to be?
So you're just drawing that. Just drawing a ray.
It's not very straight.
Oh. What is that?
Did you DIY that?
All right, here we go. So I need you to watch what I do and then you'll do it, okay? Let me get through this. So we are using this as a measuring device, okay? How wide it is. So what we're going to do is we're going to open it some distance. You don't want it super tiny. You don't want it huge, okay? Just kind of in the middle of your angle. You're going to put the point on B and you're going to draw an arc that intersects both sides. And then important, you're going to keep it the same size and go over to E and draw the same thing. So watch what I do first and then you can do it. So I put the point on B, I draw the arc through both of them, I keep it the same size, put the point on E and draw that same arc. Okay, so that's what you're doing. Go ahead and do it. Point on B, draw the arc, keep it the same size, point on E, draw the arc.
I think I made a hole.
Doesn't matter the size, as long as it's the same on both.
Yo.
Okay, so we should have this on our page. Okay, with those arcs. Let's label our points of intersection here. We'll call this A and C. And we'll call this one D. So that when I talk about them, I can refer to the points. Okay, everybody good so far? Okay, so here's the next thing that we have to do. Using that compass again. Again, watch up here first. We're going to put the point on A and open it up so the pencil is on C. Okay, so it's a specific width now. Point on A, pencil on C. I'm going to draw myself a little arc so I can see and make sure that I'm in the right spot. I'm going to keep that same size. Okay, that same size with point on A, pencil on C. Same size, point on D, and then draw that arc so it crosses the one that's already there. So point on A, pencil on C, keep that size, point on D, and draw the little arc. If your big arc isn't big enough, you might have to go back and extend that arc. Once you draw that little arc, you got a point of intersection there. Take that point of intersection, connect it back to E. And it should
Whoa.
be a 45-degree angle. And you go ahead and check it. Should be at least close. I had somebody last hour say they were 12 degrees off. I was like, that's not close.
I got it.
It is
46.
44.
I'm at like 46, pretty close.
I got 46 too.
Where was it?
I got 44.5.
That's pretty good. Pretty good.
43.
All right, any questions on our construction here?
Like
All right, again, not doing this on the homework or quiz or test. This is just during the lesson sort of
very
thing.
complicated.
So you can put it back, the stuff you borrowed, put away your stuff. We don't need it anymore. Go ahead, start working on the homework.
You videotaping the last part?